Okay guys, so in today's video we are going to be doing a little bit of testing in a different scene. And that is because if you watched the previous video, I said that we were going to try and fix our issue with our camera zooming effect that we want to happen when we go and launch the game and play the first level. But I actually forgot about that, and I wanted to make another video and realized that I hadn't solved it by researching on the internet and trying to figure out how to fix it. So we're going to put that on pause for now and probably postpone it to one of the future videos. And today we're going to jump into our Cube Quest game and open up a completely different scene and just do some testing for our levels. So if you have been following along with these videos, you would have heard me say that this game, or eventually what we want the overall outcome of this game to be, is to have levels that generate themselves so that we don't have to manually create each level by dragging and dropping blocks and everything into the game and assigning the level number to it. So what we want to do is we'll create a few levels just for development purposes and testing them, but in the future we want to programmatically generate our levels. So we're going to jump into a scene today and focus on just getting started with that. We're going to do it in a different scene because we're just doing it for testing, and then once we've got it working properly, we will bring it into our main game scene. So, but before we do all of that, if we jump into here and play the game, I've noticed that when we press play, we're not actually dismissing this menu. So I want to go in and just fix that quickly because that shouldn't take too long. So we have a script here that handles, I believe it's in our UI manager. So I'm going to open that up, and that should be this is the one, hopefully. So here, when we go and play the game, we want to dismiss our level complete. No, not our level complete. We want to, what is it called? Let's just move this to the side. So we want to dismiss our, what's it called? Start game panel. So we need to create another reference here. So I'm going to copy this and paste that in here. Then I'm just going to change this name to, I've already forgotten what it was. It was our start game panel. So let's change this to start game panel. So let's go and when we go and press the play game button, we'll do it straight away before we actually move the camera. That way we can see the zoom effect happen without all of the text and stuff on the screen. So I believe the only thing we want to do is we want to say start game panel dot set active, and that is going to be false. So we'll save that and let's just test that out, and that should be enough to get rid of our panel. So we'll click that, and no, it's not going to work because we have not dragged it into our UI manager. So we'll drag that into there, and then now that should work. So that should dismiss our game panel, which it does when we go and press the game play game button. So the overall what am I saying? So what we want to happen when we go and press that button is we want the camera to zoom into the level so that we can start playing this level. We can still play it now, but it's a bit zoomed out. So that's what we want to do in one of the next videos. But let's start working on today's plan. So I'm going to create a new scene, and where's scene? Here it is. So in the scene, I'm just going to call this test for now because we're just going to be doing some testing in here. Okay, so first things first, we want to create an empty object here, and this is going to be our maze. So this is going to generate our maze for us. So I'm going to add a new script onto it, and this is going to be called the same as our game object, maze generator. So we'll go and add that. And then what we want to do in this class, which should be, let's just drag that into our scripts folder, and then we can go and access it from here. So here is, where is it? There it is. So here's our maze generator script. And what we want to do in here is to somehow create a 3D maze only using our C# code. So what we want to do before we do all of that is we need to figure out a few things. So if we go back to our game and just press play in our, where is it? Scenes, game. Let's go to our game scene and just press play quick. So I believe we have, okay, so that's not gonna work. Because what I'm realizing now is we have these, if we go to our, how do we get out of 2D mode? So if you see here, we have all of these walls that are made out of cubes that have been stretched. You can see that they've been stretched on the z-axis with the scale, and some of them are on the okay, so they're still on the z-axis, they've just been rotated 90 degrees. Okay, but that's not what we want. And for now, in our new scene, we are going to do, well, we're going to create our maze pure only out of 3D cubes for now. We might change that later. But because we're going to do that, we need to create a cube. So let's go and create a new cube in our scene. And this we will call, well, we'll just leave it as cube because that's what we need it as. So we'll leave that like that. And then what we need to do now is we need to go to our script and we need to get a reference for this. So let's go here and say, just because this is all testing, I'm just going to make it public. It's going to be a game object, and this will be our cube. The next thing we need to do is we need to figure out how big we want it. So I am going to make it a size of, let's make it about 20 for now. So we want a 20 by 20 maze. Public int maze size is equal to. Okay, so we'll do that. And then we'll get rid of our update method because I don't think we need that yet. So here we'll make another public method called public void. This will be generate maze. Okay, so what we also want to do is, because we're going to have a 2 by, well, not really a 2 by 2, but a 20 by 20 maze. This is going to be a 2D, not really, what am I saying? It's going to be 3D, but we want, think of the maze looking down from the top as a 2 by 2 array, if that makes sense. So we're going to make an array of objects, or an array of game objects. But if you, let me draw it on the screen if I can. No, I can't, because where's my brush? So if you look here, what we want to have is, by default, a 1D array is like a certain amount of objects, just like in 1D. So it's just one kind of line. I don't know how to explain it, but this would be a 1D array. But what we want to have is a 2D array. So we want it to be on the x-axis as well as the z-axis. So we'll have a 20, just think that this way consists of 20 elements, but we also want to have 20 elements going down this way. So that will create a game objects of, can't think of the word, but if you'll get it when we start programming it. So let's go and create an array for our game objects that will house our individual cubes that will generate or create our maze later on. So if we create a public, this is going to be an array of a 2D array of game objects. So we'll call this our maze. So we don't put any numbers in here because that just tells it how we could put 20 in it, but we'll leave it out for now just in case we want to increase or decrease the size of our maze. So we'll leave that like that. So now we need to somehow generate our maze. So when we generate our maze, we're going to tell it how big we want it. So let's go and say int maze size. Actually, let's just say size, because if we say maze size, it might get confused with our variable over here int. So we'll leave that like that, and then in our start method, we will call this generate maze with our maze size as a parameter. So we'll save that. And now in our generate maze function, we need to go and generate our cubes to form our maze. So to make a 2D array of cubes, we're going to need 2 for loops, one inside the other. And that is going to be done like this, I think. So this is just testing, so I don't even know if this is actually going to work. But let's go and test it out. So let's create a for loop saying for int. We're going to keep it, we're going to call it x because we're going to work on the x-axis and the z-axis. So we'll keep our integers called x and z just so we don't get confused. So to start off with, we will say for int x is equal to, we'll start at 0, and then what we want to go up to is x is less than our array size, so it will be size. And then we want to go and say x plus plus, close our for loop off, and then open up another, what's it called? Another for loop. So why is this not working? Int x is equal to 0, where x is less than size. Why is it not working? Am I not seeing something? X is less than size, x plus plus. Let's just do that again. For int x is equal to 0. Oh, that's why it's supposed to be a semicolon. X is less than our size, and then same thing, x plus plus. Okay, so that should work. So now we'll get rid of those because we already have them over here. So I'm going to copy that and simply paste it in here, and then just change our x to z. So that should be fine. And then let's open up some curly brackets. So in here, this is where we're going to instantiate our cube at each location. And what we need to do here is we need to go and say, go and place this block at x and z, if that makes sense. So let's say maze, and we'll put x and z because that's where we want it to be. And that is going to be equal to instantiate. This is where we're going to need our cube. So let's go cube prefab. And then we want to instantiate it at a new vector 3. And this is going to be at x. And then we're going to leave it at 0 on the y-axis because we only want it to, we don't want it to be at different heights. So we'll put 0 for y, and then our z for our z. And then we don't really want any rotation. So let's go and say quaternion dot identity. So that's no rotation. And that should pretty much be it. So fingers crossed. Let's go into the game and see what we got. So this is not going to be a maze to start off with. This is just going to be a flat, or it's not going to be anything really. So let's go and see. Okay, so we didn't drag that in. So we need to drag in our cube. But let's just go ahead and create a prefab out of that. So we'll drag that in there. And then we no longer need that in our game scene. So we can drag our existing cube prefab into there. And then I'm just going to reset this, and then we can go and play the game. Okay, so let's press play. And now you should see a flat surface of cubes, but you don't. But why would you? Right, so let's have a look and see what's happening here. So we should have got, or at least we want, well, at least I wanted us to get just like an array of cubes right next to each other, so it would look like a massive field or flat surface of cubes placed next to each other. Okay, so let's see what we're doing. We are getting our maze by saying generate maze. So we'll save that. So I'm just going to get rid of this maze quickly, and I'm just going to say instantiate our cubes at this location. So let's go and press play and see what happens. So if we get a maze, so this is what I wanted to get. but I believe this is not the correct way of doing it. So this is a good start. We'll start like this for now, and then we'll work on it from here. So let us go and figure this out. So the correct way, or at least the correct way I think we should do it, is to keep it like this. But I believe we need to go and tell it how big we want it to be. So let's go back into our script here and say in our start method, we need to go and create a new maze. So here we'll say maze is going to be equal to new game object, and our size is going to be our maze size by our maze size. Okay, so that should be fine. So now let's go and test that out. Did we change it in our for loop? Yeah, we did. So if we press play now, we should see that we should get the same thing that we just got before. So we do. So here is our maze. So let's rotate this around so that we're looking in the correct direction. Okay, so here's our maze. Well, not really a maze, but here is what we got so far. So in the future, we are going to get rid of some of the blocks that are in the middle so that we can generate a actual maze. And then once we've done that, we need to figure out if there is, well, before we do figuring out, we're going to place a starting point in the scene, same as what we have in our existing 2 levels. We're going to place a starting point as well as an endpoint, and then we're going to try and figure out if is there a path that we can follow from point A, which will be the starting point, to point B, which will be the endpoint. And if there isn't, we need to go and generate a new maze until we get a maze that has a path. So let us do something else. Now, what we want to do is we want to create a few new cubes. So let's go and create another cube. We'll create a 3D cube, and this will be our edge cube. And then I'm going to create another material. So let's create a new material, and then we'll make this color black. And then on our edge cube, we will apply that material. And then what we can do with that cube is we can bring it into our prefabs folder. Okay, so we're going to use this cube as a edge cube. So instead of having all white cubes, we'll change the color of the white later. But what we want to do is on the edge of our maze, we're going to have this edge cube that we've just created so that we can actually see the outside of the edge. And we always want the edge to be solid. So when we go and remove some cubes from the inside, we don't want it to remove any of the edge. So we'll figure out how to fix that later. But let's go and create that reference to that edge cube now. So I'm going to create another game object, and this is going to be called edge cube. And then we can go and drag that in over here. So here's our edge cube. We'll drag it in there. And then we need to figure out how to determine if we are on the edge or not. So because we have a maze size of 20, I believe the edge of the maze will always be at 19 or 0 on the X and the Z axis. So if we go to our scene view, you can see here the X axis going up on the Z axis, if that makes sense, is always going to be 0. So all of these here are going to be 0 from that block to this one, and on the X axis, and from this one to this one, all of the Z values are going to be 0. And the same thing from here. This is all going to be 19, and then this is all going to be 19 on their respective axes. So what we can do, we can use that to determine which block we want to go and place at that location. So to do that, let's create another method here called public. Actually, we can make this private. We're going to return a game object, and we'll call this get cube. And then in here, we will pass in our int x, as well as our int z. So that's the location that we want to place the cube at. So let's just go and return our cube for now. So we're going to return our edge cube, and then what we want to do is we want to create another public int minimum maze size, and that's always going to be equal to 0. And then we also want a public int max maze size. We're not going to assign that a value because we'll do that in our start method, because when we change the size of our maze, we want it to also change the maximum size. So because the maximum size will always be 1 less than the maze, we can simply go and say max maze size is equal to maze size minus 1. So we'll save that like that. And then now we need to determine how we are going to assign our different cubes. So before we go and instantiate it, we can simply call our get cube method with our x and our z values, and that will return the correct cube, or it should return the correct cube that we want to go and place in that position. So before we do that, let's go and say if our well, let's go and create a point, so our current point that we're working with. So let's go and say var current point is going to be equal to a new vector 3, and that's we're gonna get the x value from our parameter. Our y value is going to be 0 because we always work on the 0, and our z will also be 0. Okay, so we'll save that like that, and then we can say if our current point on the x-axis is equal to our minimum maze size. Actually, let's go and change that to minimum maze value, and then we'll change the same one, max maze value, like that, and then we're just going to copy that and paste that in there. Okay, so that should be fine. That sounds a little bit better. So now that I'm thinking of this, we don't really need this quite yet. We'll use that later in the future, so we'll get rid of that. For now, we can just use our x and our z value because we're only working on the outer parts of the maze, which the value on the outer part of the maze only changes, well, it doesn't really change because it's always going to be 0 or 19 on the x and 0 or 19 on the z, the z axis. So let's go and say if x is equal to our minimum maze value, or or z is equal to the minimum maze value, then let's go and return the edge cube. We can copy and paste that and change our minimum to our max, and the same over here, minimum to max. Save that, and then we just need to return our cube over here instead of our edge cube, because we only want our edge cube to appear when it is on the edge. So we'll save that, and then let's jump into our game and press play. So I fully do not expect this to work, but you never know, we might get lucky. So what have we got here? Okay, so it's working on half of the maze. So let's see, what is this? This is going to be 19 and 19. Okay, so that's a bit weird. Edge cube, what have we got? Minimum maze value is 20 minus 1. I mean, minimum is 0. What have we got? So here we've all got, these are all at 19 on the z-axis. Did we do this right? X, X, and Z, Z. So we've got here Z is, X is equal to minimum maze value. Let's go and flip this around and say X is equal to minimum maze value, or we'll just put that back, or X is equal to maximum, and then we'll say X Z is equal to minimum, and then X Z is equal to max. So we'll save that and paste, well, we'll just go and play the game and see what we get. So hopefully, do we get anything different? No, we don't. So we need to try and figure out why it's not doing anything over here on this side. So this is all X. Let's just comment one of these out and see what happens. We save that and paste that, or run the game like this. See what happens. So we should only get one side, okay, which we do. And then that doesn't really make sense because this Z value is on 19, and this one is also on 19, but the X axis is also on 19. And then these ones are also on 19. But the Z is also on 0. So that's a bit strange. So we can go and uncomment that. Save that. Let's just get rid of our -1 quick and see what happens if we save that and then go and play the game. Do we get any different? No, we don't. Okay. So that's a bit strange, but anyway, we're getting somewhere. We got a lot further than I thought we were going to get, so that's fine for today. So probably in one of the next videos, I think we might go back to trying to figure out our zoom effect, because I'll do some research onto that and how to fix it. But later on, we'll come back to our testing, or trying to test and trying to create a 3D maze for our game, and then we'll try and figure out that issue, and then we will also try and start working on our starting point and our end point and trying to figure out if we have a path from point A to point B. But that is it for today. So thank you for watching if you made this far, and I will see you guys in tomorrow's episode. Goodbye.